So our first panel today is focused on technology. The moderator for this panel is Sean Burkholder, an assistant professor of landscape architecture at Penn State University. And our participants include Jason Soll from the University of Texas at Austin. He is an assistant professor there, and he has backgrounds in both architecture and landscape. Second participant is Tobias Haller, who's an architect from Germany, presently practicing in New York and teaching at the New York Institute of Technology. Our final set of panelists for the technology group is Brad Cantrell from LSU and his research partner, Natalie Yates, who's at the University of Washington in St. Louis. Our first speaker will be Jason Soll from the University of Texas in Austin.
Okay, good morning, and I'd like to extend my thanks also to Jason and the others. It's an honor to be here, especially to be included with the other panelists that will follow throughout the day. In 2002, The Economist newspaper proclaimed that if Texas did not already embody America's future, its size and ambition would enable the state to get there first. Citing the state's natural resources, intellectual capital, and technology and finance industries, the essay noted that the energy sector would play a prominent role in the economy's diversification. A leading producer and consumer of energy, Texas has, over the past decade, initiated some of the nation's largest energy projects in order to capitalize on the state's vast geophysical and geological resources. During this time, shifts in energy costs, development rights, and recovery techniques provided necessary triggers or incentives to expand, if not accelerate, the implementation of wind generation and natural gas extraction technologies. My intent today is to trace the economic, legislative, and technical measures that led to the development of these wind farms and shale gas fields, and begin to note how each landscape reprograms or reconditions existing land uses, affects water resources, and then propose opportunities by which mechanical and biophysical processes could remediate shale gas byproducts. I guess as a disclosure, note that as an employee of the University of Texas at Austin, the endowment comes predominantly from oil and gas royalties. So I'm getting that out there first. Okay. Wind power was first introduced by the railroads in Texas in 1860, and it was utilized as a way to pump water for operations, begin to set up infrastructure for rail towns, and even utilized as a way to set up agricultural experiment stations as a means of enticing individuals to come into, at least in terms of the western part of the state, a fairly semi-arid landscape. Combined with well drilling and barbed wire, the windmill essentially became a part of a tripartite set of technologies which transformed the landscape from open range to fenced ranch. It was subsequently superseded by the electrical pump and essentially became into disuse until the last part of the 20th century. At this stage, the state did a couple of things in 1999. The first was the passage of what is known as Senate Bill number 7, which established the Texas Renewable Portfolio Standard, and had a couple of different aspects to this bill. The predominant one was that by 2025, they would be producing 10,000 megawatts of energy from renewable sources. The second would be to establish a system of renewable energy credits, which valid through 2019, would enable those power producers who had renewable aspects of their portfolio to be able to trade to others who did not, in order for them to begin to comply. So it sets up a type of trading system in regards to the renewable electricity. And then therefore, all of the power producers within the state would conform to the renewable portfolio standard. As a result of this, the wind industry essentially sunk $1 billion into manufacturing and wind farms across the state. As you can see on the the right-hand image there, the areas in blue are where all of the wind farms tend to be sited. This is, as you can see in the drawing here on the left, that's where the areas tend to be where you have a Class 3 higher or higher rating in terms of wind power output. But they had a problem, which was that most of the people in the state don't actually live in the western part. And the question began to be, how do we actually get the electricity from the areas where there is high wind to the population centers in the eastern parts? The other is to begin to think about how Texas, which is its own energy grid, there's the three energy grids within the U.S. You've got the western, the eastern, and then ERCOT, which is the Texas grid, is to tap into the eastern and western grids as a way of beginning to distribute electricity across the U.S. And in order to do that, in 2005, the state passed Senate Bill number 20, which essentially allocated $5 billion for the construction of a series of AC/DC high transmission lines from what are known as competitive renewable energy zones, and then taking that electricity into the other parts of the state. And at the moment, the CREZs are slated to be completed by December 2013, provided that they can pass the resolution to offset the difference of the $5 billion. This cost has now risen to $6.79 billion by increasing the electricity rates across the state. As a result of the investment, as you can see at the moment, the state met the 2025 initiative in 12 years and is now at the one of the largest wind-producing areas in the world, if not certainly within the United States, well ahead of Iowa, which has a little bit over 3,000 megawatts. But the subsidies have done a number of other things, which is that it's begun to transform landscapes in different ways in regards to how agricultural areas are being utilized. One of the issues is that by setting up the wind farm as a cash crop, the intent is to begin to wean certain types of agricultural production away from high water intensive crops now to essentially grazing, and then the royalties which come from each of the turbines themselves. And while that's certainly been of benefit to a number of individuals who operate at the smaller ranch level, there have been some who are seeking to take advantage of the state's renewable energy initiatives in order to sort of set up some rather large projects for their own particular benefits. And this is where the story gets to be a little more interesting. On July 28, 2008, Texas oil magnate and billionaire T. Boone Pickens released what is known as the Pickens Plan, utilizing a combination of print media, television, radio, and internet advertising. A three-step 10-year energy platform, the plan is intended to facilitate the United States' transition toward energy independence. Led by private industry, step one would essentially transform the entire Midwest into a gigantic wind farm, supplying what would be 22% of the nation's energy needs. Step two would construct the necessary electricity transmission infrastructure, connecting all of these farms to the metropolitan centers across the U.S. And then step three would be to replace crude oil-based fuels with natural gas, which would require the transition of all of the automotive fleet to natural gas and require the construction of a natural gas distribution network. Now, it might be unsurprising to you to know that T. Boone Pickens happens to be the largest owner a single owner of natural gas resources, not only in Texas but also Oklahoma. He also happens to be the largest single owner of one of the largest aquifers in the state, which is known as the Ogallala Aquifer. And he intends essentially to utilize a loophole in the state laws in order to translate the electrical power from the wind farm, bundling it with the utilities, and then shipping water into the Dallas-Fort Worth region. He does this by essentially setting up on 8 acres of land, no less, what is known as a state water supply district. There are only 5 board members, 3 of which are executives in his firm BP Capital, and the other 2 are his ranch managers. And the intent is that he would essentially, if you can notice the image on the right, building in the pipeline and then the energy transmission corridor to this particular area, Lake Bridgeport, which is there to the left, which happens to be one of the 6 drinking water resources for Tarrant County or the Dallas-Fort Worth Metroplex. His plan at some level, you could say, is visionary in the sense that at the moment, or at the time, it was one of the only conversations about how to deal with energy at a national level. But I think you could also begin to question if the offsets that the plan proffered were not grounded in the fact that he happened to own extensive land holdings and mineral rights, as well as the sort of loophole that he was seeking to take advantage of. And the fact is that by taking advantage of that loophole, he as a private individual has right of eminent domain. Conventional drilling in the Barnett Shale, an unconventional natural gas play underlying 23 counties surrounding the Dallas-Fort Metroplex, which if you can see, it's a very large purple splotch there in the middle of Texas, has always rendered a type of recoverable volume of gas. The problem is that at the time that individuals were drilling through it vertically, over time the well would essentially not provide the gas that would compensate for the financial resources sunk into drilling the well and then transporting the gas itself. And so the advances in recovery techniques that have been combined with the rising price of natural gas have provided the necessary triggers to begin expanding these operations. In 1981, George Mitchell, president of Mitchell Energy, initiated a series of fracturing studies to stimulate the low permeability shale, connect isolated pores, and extract the gas. And I should note, George Mitchell is the same individual that hired Ian McHarg to design the Woodlands, which is the ecological community outside of Houston. Building off of technology developed in the 1940s, Mitchell refined the fracture fluid as a mixture of freshwater, sand, and chemical additives. And the chemical additives include a number of things such as surfactants, friction reducers, biocides, and scale inhibitors. You can see here it's a typical section through a hydraulic fracturing well, along with the horizontal drilling. And the intent is that you essentially establish the vertical bore well. You have to set up a type of cap as you pass through the aquifer. And then as you begin to hit the shale layer, you turn horizontally in order to then begin to fracture it. The sand acts as a proppant in order to keep the fractures open and permit for gas mobility. And then the chemical additives are just simply there in order to protect the drilling equipment. They account for only 1% of the drilling fluid itself. If you've ever seen gas land, however, I think you can be aware of their particular impacts on a number of subsurface water resources. In 1999, Mitchell coupled hydraulic fracturing with horizontal drilling in order to stimulate a greater area per each vertical well. While these practices made recovery of the Barnett Shale's large play technically feasible, sustained gas prices of $4 per 1,000 cubic feet that have occurred since 2005 have ensured that the process provides operators a financial return, as evidenced by the increase in drilling permits from 961 in 2003 to 17,916 over the next 7 years. Currently the nation's largest unconventional field, the play has helped Texas account for 30% of the nation's annual natural gas production, with yields in the Newark East field averaging over 716 billion cubic feet. So this is the area that's predominantly where the Barnett Shale is located. You can see the orange lines snaking around. That's the sort of eastern boundary of the Barnett Shale. The primary core of the field is the sort of pink area to the top, which covers Wise, Denton, and then to the south, Tarrant County, which is where Fort Worth is located. All right, and you can begin to see the number of wells within the Newark East field. There's a fault line which runs through, which accounts for why there's a pretty noticeable band where no wells are located at all. All right. The proliferation of permits and active wells parallels an increase in the number of leases signed by the region's operators. Taking advantage of the state's separation of the surface estate from the mineral estate, rural and urban landowners, as well as municipal, state, and federal agencies, are seeking to literally cash in on the Barnett Shale's estimated 25 trillion cubic feet of reserves. The leases have begun to transform a number of areas, including farmland. And in this particular case, this is true economic diversity in Wise County. So you've got cattle grazing there on the right, you've got the oil there, and then you've got the natural gas condensation wells there to the left. Begin to see these, essentially the condensate wells in a number of suburban areas. All right, so they're next to houses. And then, of course, on other types of ranches. And you can begin to, as the slide notes, the amount of money that each well begins to give the landowners themselves. But it's not only the private landowners. State and federal agencies also take advantage of the lease agreements. So the LBJ Grasslands, which is located in Wise County, has 91 active wells, and then the money is turned over into the Wise County municipality. There are a number of problems which come from the technology itself, however, which is the fact that the drilling operations utilize quite a bit of groundwater. Fresh water is required in order to fracture the shale itself, and each well on average utilizes about 5 million gallons of water. Some take as much as 7 to 8 million gallons of water. There are a number of sort of infrastructure which has to go into place in order for this to occur. You can see on the right of the slide, there's a pond there. So they build the pond to essentially hold all 5 million gallons of water. Otherwise, they have to truck it in, which is actually quite expensive. Drill rig gets set up, and then there's an impoundment pond, which once the fractured water moves through the well, at least 40% comes back to the surface, and then they have to store this in terms of disposal as a result of it becoming contaminated from both increased salinity, which is about 2 times what seawater is, as well as other chemical byproducts which come out of the petroleum residues themselves. As a way to sort of give you an idea of what the scale of 5 million, 7 million gallons of water is, the reflecting pool on the National Mall is about the right size. The use of groundwater as a part of the fracturing operations at the moment occurs for only 3% of the total reserves of the Trinity Aquifer, which is the area in blue. However, as the number of wells is beginning to increase, projections are that groundwater use will also increase to about 20%. And although this isn't necessarily a problem in terms of the total amount of groundwater which is available, you do begin to have areas in which you have groundwater depletion, which are the areas in red, that start to affect the agricultural operations within those particular regions. What happens is that although it's not depleting the aquifer in its entirety, it's pulling the water down to below what the wells for those particular agricultural operations are, and therefore the landowners either have to abandon the well or re-drill much, much deeper in order to have water if they can get to it at all. But it's not only the rural areas which are affected by this. Within the city of Fort Worth, as you can begin to see just in this map here, there are over 2,000 wells which have been drilled, and they're next to a number of things such as shopping centers, parks, schools, and so forth. And this particular drawing is demonstrating the concentration of the wells in relation to the Trinity River, in which essentially drill operators snake pipes over the levee of the river directly into the river itself and then pull water from it. And as the city notes, they at least pay twice what a typical homeowner does for the water itself. And you end up with around $24,000, at least for the initial fracking of the well. And of course, you end up with a number of infrastructure added to the park system itself, moving over the sort of bike path. And then, of course, pipelines which snake through parts of the park itself. One of the negative aspects of the use of the water is that in the drilling industry will note, well, it's only 1%, and if we take the entire water budget of the area, 50% is utilized, at least in Fort Worth, for watering of lawns. But the fact of the matter is that in the watering of the lawn, you still get the water tied into the hydrologic cycle. The fractured water, because it is contaminated, they have to dispose of it in one of two different ways. One is that they place it in ponds and allow it to evaporate, and then the sludge is simply trucked to a landfill. Or the preferred method is that there are disposal wells located throughout the region, and they pump the water about 10,000 feet into the ground, which effectively locks that water into the ground and then removes it from the hydrologic cycle. One of the aspects that the industry has done some experimentation with is ways of recycling frack water in order to reduce the amount of groundwater that they utilize. And this is accomplished through a number of different ways. The first would be through essentially reverse osmosis desalination. They have a number of mobile units which travel to a number of the different sites, and then through that process they get up to 85% of what comes back to the surface in order to be utilized for refracking other wells. But you end up, as a byproduct of that, a pretty heavy saline concentrated brine solution. So from a speculative point of view, one of the ideas would be to rethink the manner in which their water use could lead to other types of landscapes. Within this region, there happens to be one of the largest aggregate quarries in North America. You can see it just south of Chico. There's 4 operators there with about 5,000 acres of mines. And as you can see with the number of the sort of infrastructural lines running through the map, if one could begin to take advantage of the existing easements, one could essentially place another pipeline by which the wells could then pipe the frack water to an abandoned sort of pit and begin to utilize these as resources to recycle types of water. The fresh water itself could essentially be utilized either for additional fracking operations or placed back into the aquifer. Or, in terms of the concentrated brine and the petroleum distillates, if you utilize a type of halophilic bacteria, you begin to utilize biophysical processes as a means of remediating the water itself. So by combining these two types of sort of mechanical and biophysical processes, then the frack water becomes less of an environmental hazard than it is at the moment. As wind and water and unconventional gas plays are developed nationwide, energy speculation, generation, and transmission will need to evaluate questions of productivity in context of the aftermath of its waste. Towards these ends, these measures that enable the landscape's transformation position technology as a cultural practice inasmuch as it embodies a technical one. Thank you.
Good morning. My name is Tobias Haller. I teach at NYIT in Manhattan. In fact, it's not just Manhattan, it's also, we have two campuses, and one in Manhattan, and what is arguably the most dense place in the States, Columbus Circle, and we have one campus in Old Westbury in New York, in Long Island, which is probably the least dense place. Not quite. I think probably parts of Texas have less population. But I'm telling you this because it actually has an impact on my work. I'm teaching in both campuses, and I'm constantly between those densities, you know, an architecture school in an office building and an old stables building. So it's a very extreme contrast. I'm showing today a design research project, essentially a competition entry that I did with a couple of people. One of them is Anna Serra, who's a sustainability consultant at Bureau Happold in New York, a student of mine, Katie Mulry, and a friend of mine, Sven Peters, an architect in Brooklyn. Before I show the project, I'm just showing a couple of slides of the themes that were on our minds when we entered the competition. The competition was the Build a Better Burb competition that was organized by the Long Island Index. It's a local organization in Long Island that is, they're saying they're collecting data about the region in order to change policy. That's kind of what they're, as you may know, Long Island is a fairly conservative place and a very fragmented place from a legislative point of view, so any change is extremely difficult. And I think the Long Island Index is trying to present the issues in a way that they hope that they will change policy. So this image is showing the same place in a couple of different times, and it's the on the left we have the what's called the Hempstead Plains that is was once covering most of western Long Island. It was the only prairie ecosystem east of the Appalachians. It's down to a small area that's surrounded by highways next to a shopping center. So that was, up to, I guess, 1700s or 1800s. This was covering most of the island. Then we have the same place in the, around 1900. This is a place called Island Trees, New York. This was a potato farm, a very intense agricultural region. And then it became what you probably all know, Levittown, New York, the first post-war suburb. So you have, within a very short period of time, a transition from a natural ecosystem to an agricultural system to a suburban structure or system. And Levittown is fascinating. We were wondering about efficiency. How can suburbia be efficient? And that's usually not what you think when you think about suburbia. You think of it as an extremely inefficient urban system. Just an aspect of Levitt's work was the utmost efficiency in construction and also in how to sell these for little money. Whenever you think about any urban structure or suburban settlement pattern, it's always about, there's always a transportation infrastructure that is the backbone of any development. I actually used a local example. This is on the left is an example from Cincinnati. That's somewhat local, isn't it? This is an advertisement for lots, and they're advertised by proximity to the train station. And of course, you have the suburban, the highway infrastructure in New York. That was Robert Moses who built all the highway system and enabled the post-war expansion. As you all know, we had a rapid development of urbanization, suburbanization. Another thing is super studio, the total urbanization of the landscape in a very abstract system. But there's an interesting relationship between the nature and the urban structures. An early advertisement for a suburb in north of New York City, and what I thought was interesting here is that if you look closely, you see that they were doing Photoshop back in the days to enhance the nature. There's some trees that are collaged in. The clouds are kind of increased. So there's an intensification of nature as part of the package to sell suburbia. And this is a photo by the artist Bill Owens. It's called Untitled in Suburbia. Of course, the much vilified suburban lawn that can be installed in a day. And in the 50s, you have a carpet that has characteristics of the lawn, and you have a lawn that has characteristics of the carpet. So you have an interesting hybridization between nature and architecture, so to speak. And this is, as you can see, I didn't find a slide, and something that I think, speaking to landscape architects, we can probably skip over fairly quickly, but the idea that nature is not something that is separate from human structures, but it's actually just another infrastructure. At least that's how we try to look at this. And this goes back to what Matt Coolidge said last night, that there hasn't been, I don't know what he exactly said, but there's no molecule on Earth that hasn't been touched by humans. And Daniel Jensen, he's a tropical ecologist at UPenn. He does restoration work in Costa Rica, very influential over there. And he said that there are no wild places on the planet anymore. It's all gardening. We have to be good gardeners, but don't mistake that a rainforest is something natural. It's just something that we have to understand, and we have to take care of it, and it's going to be very productive and very good for us. So that was important. So the competition was essentially for a downtown redevelopment of a certain downtowns in Long Island along the train station. We did not just want to look at this. We somehow couldn't help ourselves to look at the whole island, and we asked ourselves, what if Long Island was an actual island in the sense that it is it is actually in the psyche of the population. It is actually very important. It is, you can't just, there's only a couple of bridges and tunnels. You can't just drive to Connecticut quickly. You have to go through the bottleneck of New York. So the idea that it's an entity that has limits, and it's unable to extend beyond those limits. So we kind of took that idea of the island as like, well, what if this was actually an island that worked within itself? It created all of its food, generated all of its electricity, and dealt with all of its waste. So the first thing we looked is what is, well, before we did that, this is a little calculation I just couldn't help but make. And again, because of this teaching at both places, we have Manhattan, a density of 70,000 people per square mile. We have Long Island, density of 2,000 people per square mile, and then the obvious comparison is what if you condensed all Long Islanders at the density of Manhattan and you moved them all to the border of Queens and Brooklyn? You would have essentially another slightly larger version of Manhattan, and you could have all the rest of Long Island be empty. And for a moment we thought, well, this is our proposal for the competition. That's what we're gonna do. It's wonderful. I mean, who does not want to live in Manhattan, and who does not want to have this gigantic open space that we could renaturalize, we could bring back the old ecosystems. But of course, we thought that would probably not get us very far. So we looked at what is actually there at the moment. And we studied the land use maps. So it's predominantly covered in what we termed the suburban fabric. That's sort of a generalization, but for the purpose of this competition, we did that. There's 5% agriculture. It's mainly winemaking on the North Fork of Long Island. And there's 11% open space. This is protected open space. It's not, there's more open space, but the other open space is up for grabs for development. And then we thought, okay, how would we want to change this? And one thing that we started was, well, what if actually it was a balance between built and unbuilt? What if we had 50% open space on Long Island? And what happens if we have to organize the rest? How much area do we need for food production? we try to look at different metrics of a required area, and to be quite honest, it's ranging drastically when you look at what the USDA says is required. When you look at the urban agriculture research, Des Pommiers at Columbia. So we try to figure out a number in the middle, and with the high efficiency hydroponic 2-story greenhouses, we didn't want to have skyscrapers of farms. It didn't seem appropriate. We calculated that with 8% of the land, we were able to feed all Long Islanders. And then we said, okay, we have to leave. We can't do the thing where we move everyone to the border of the city. There has to be something that we keep of the suburban fabric, because otherwise there would be no acceptance. So we said, we're only going to modify the density in the downtowns, and the downtowns were defined as the half-a-mile radius around the train station. That's a classic transit-oriented development radius. And then we calculated what is the density of those downtowns if we actually keep all the rest of the fabric intact. And numbers crunching. These downtowns will have 23,000 people per square mile, and that seems extremely dense compared to the current condition. But if you compare with Brooklyn, for example, it's not even it's less dense than Brooklyn, and so we see that was encouraging. That seemed like that could just from a density point of view that could work. Then the question is where would we downzone? Where would we upzone? I mean, we had this idea that we would develop a 50-year plan of how certain areas could shrink and certain areas could grow. Going back to the transit infrastructure as the backbone of any development, we looked at the Long Island Railroad. It's the busiest commuter railroad in the United States. And what if the organization of the island was based on that? Like it used to be small towns connected by the Long Island Railroad, but that has long been changed. It's the highway infrastructure that is dominating the organization of the land. So we try to look back and see what if we actually can use the train stations as the generators for a new land use. So we kind of took those points, and then we the favorite Voronoi subdivision pattern that I'm sure you're familiar with, a very simple geometric subdivision. that now takes the train stations and creates polygons that are based on proximity to those train stations. So in a way, this is like a transit-oriented Voronoi application, creating polygons where each area is closer to that particular train station than to any other train station. And interestingly enough, where there's lots of train stations, there's smaller areas, and when you go out east, there's much larger areas. So we looked at what is the density of one of those, overlaid it with the density maps, and figured out how many people live there, what is the capacity of the downtown, given our density, and then we had this idea that we would downzone the outlying areas of each of these polygons and increase the downtowns, and then we generate a kind of a pattern that would look something like this. So this is kind of a roadmap in terms of density. This has now 50% open space. The farms would be located in those in between in the open space, and you would have these very small but very high density towns around the existing train stations. You can see one of those farms in the foreground. This is actually where Levittown used to be. We're wiping out Levittown and bringing back farms and nature, so we're kind of reversing the process to a certain extent. The people of Levittown are not happy about this. Then we look at the transportation, and you can't do you can't have everyone take the Long Island Railroad because it is a classic spoke and hub system with New York City, so there's a great east-west connection, but there's no connectivity north-south. So the idea was to use eco-boulevards, to use Urban Lab's term, to use the existing highway infrastructure and retrofit them with light rail, and also have them be part of the water management infrastructure. Hybrid bus systems. We essentially used all the best practices that are currently existing for how would you organize a community or a region with public transportation. We're not saying there will be no more cars, but they will be drastically reduced. The farms centered in the green areas. We call it the green belt. This is basically a before-after of a renaturalized Levittown. The farming would consist of small-scale farms that are more community-oriented, kind of an incremental greenhouse that could be done lot by lot, because obviously you can't just do this at once. But the idea would be that over the course of time, that the city would buy back the houses when people actually want to move, and this would happen slowly as a patchwork over time. We would have a more high density kind of agricultural production in the strip malls. We have waste to energy plants. So this kind of we call those areas the kidneys. It's where all the waste gets treated. And this is the two diagrams of how we imagine this would actually be a 100% energy generation. This was Anna's work at Bureau Happold, is trying to figure out what is the actual energy demand, how can we reduce it, and this obviously is these are again the best practices. These are passive house energy standards for existing and new construction, reducing the energy demand, and then using wind along the south shore of Long Island. We did calculate that we would need a wind farm all the way from Queens to Montauk. It was 100 mile of a big turbines combined with current. We could talk probably more about this. Essentially, it's also a zero water system. No more depletion of the aquifer. The aquifer is in big trouble in Long Island. And there's actually it is actually a climate where this is actually possible, right? There's actually plenty of wind and there's plenty of rain. So capturing rainwater, cleaning it for up to potable is it's feasible. So none of this uses technologies that are not yet existent. It's all just based on what we could do if we had the political will. And part part of the point of this proposal is that it's not, don't say it's not possible from a technological point of view. It is actually quite possible to do this, even though it sounds very ambitious. There are other issues. This was a previous iteration of the farms. And then, we had to comply with the competition who wanted actually to see what does this mean for a downtown. So we picked a downtown. This is Hicksville. 5? Oh, that's okay. That's plenty. Downtown Hicksville. It's a classic commuter downtown. Lots of parking lots. There's no real spatial definition. So we developed, these 4 strategies. The first one we called Fix a Block. It basically, takes. I presented this to new urbanists, and they loved it. I don't at all, consider myself one, but I have to admit these are some of the principles that they're advocating. So you build to the lot line, you activate the sidewalk with program, you have the parking covered, and you densify on top of the parking structure. So it's a little diagram of how this could work. The shopping malls, the giant underutilized parking lots would be populated by this typology. We call this the mall chopper. So you subdivide it. You still have parking. Create this, and then there's residential fabric in the area of the downtowns. We call this residence. We didn't actually draw this because this is a classic typology, the accessory dwelling unit. Densify your backyard. And then we felt that there needs to be a town square, like an old-fashioned piazza that celebrates the transit, so that this would be along the train station. Put in a nice, fast German high-speed train, and like a slightly higher density around there. One of the problems for Long Island, there's no diversity of housing stock. It's only single-family homes, and young people and older people that are the prime target of this type of housing. They don't actually have places. They don't find places to stay. So this is my presentation. Thank you.
Okay. I guess we're ready to begin. Natalie and I today are looking to present somewhat a body of research, so kind of some of our current research that is slightly more abstract in communication systems between devices and ecologies, and then to kind of look at how that attaches itself to a couple of speculative projects. To start here, moving into this, many explorations in responsive systems focus on the process of sensing phenomena and responding physically through automated systems or artistic interpretations. The results often represent gizmos or art installations. The manifestation of these concepts stem from the world of physical computing. To Mike. Better? Is that better? Hello? There you go. Point, 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 point. All right. So the manifestation of these concepts stem from the world of physical computing, the interface between digital and analog to process information and drive mechanical devices. This process of hands-on design is an important aspect of our explorations and forms the tangible relationships between biotic and abiotic systems. The research we are presenting rests firmly in this realm of prototyping and physical computing and begins to conceptualize a framework that accepts the complexity of broad ecological systems. It is an attempt to frame how we vision connections between the biotic and the abiotic, flux and stasis, prosthetic and cyborg. As we move forward, we intend to present a range of views that focus on methods of feedback, nuanced ecological management, and speculations on future environments. So I'm going to let Natalie take over for a moment.
Good morning. So as designers, we're challenged to establish meaningful connections between users and the built environment. The built environment is comprised of various disparate systems, including ecological and or biological systems, which consist of physical structures, functional processes, and ecological mechanisms. We can consider that evolution, interaction, behavior, and development occur within these systems and create communities in which we can monitor water quality, commodity production, environmental problems, and energy production. We also have social and cultural systems, which correspond to institutions, organizations, entities, or groups in relation to each other, and patterns of behavior. Contained within these are notions of ideology, knowledge, beliefs, attitudes, values, goals, history, practices, experience, and habits. Then we also have technological systems, which negotiate between the ecological, biological, and the social, cultural, consisting of the use and knowledge of tools, methods of organization, techniques, skills, processes, adaptation, and control of the environment. Embedded sensors and responsive infrastructures permeate the landscape, many of which are so integrated into daily life that we don't even notice them. So as designers of the built environment, we engage these contrasting ambient local systems that make up site context, giving meaning to and shaping how we use and associate with a place. In an effort to enable sustainability and adaptability, we need to be able to compress and exploit the intricacy of context to create connections between ecological and social systems, fostering communication between digital and analog, abiotic and biotic systems. Therefore, we must take into account the layers of technology that affect the environment and find a method of communication that is accessible to designers. By focusing on the context that is made up of existing processes, designers can be more equipped to accommodate difference and flexible relationships. Designers, architects, and artists challenge the notion of static structures and passive objects. Smart, responsive spaces and reactive objects populate the growing discipline of interactive design. Data recorded by sensing methods is usually filtered, reduced, and refined to become manageable. When diminished in this way, valuable pieces of context can be lost. To address this loss of data and therefore complexity, we look to the concept of abstraction layers used in high-order computing. Essentially, in computer architecture, there is a series of abstraction layers that operate between the physical hardware and the software that runs the hardware. These layers hide the implementation details and differences between the hardware so that they can function in the same system. While inessential details are hidden, they are not lost and can be retrieved in the event of later necessity. Abstraction makes it possible to change the quantity of information represented, allowing a reformation in a simpler formalism to become possible, while preserving the quantity of information involved. Borrowing the concept of abstraction layers, we can conceptualize a method of merging disparate systems such as ecology, technology, and culture that link each system, preserving desirable properties while allowing complex disparities to be hidden. We can find common data points in temporal, ephemeral, and physical elements that describe spatial phenomena, creating linkages between responsive elements and the built environment. By separating these characteristics and hiding details, we can then compare disparate systems without losing essential contextual data, allowing the opportunity to create evolving organic interactions between systems. Typically, sensing technology is used for the specific purpose of recording. Sensing methods are direct interfaces between environment phenomena and explicit binary data, which create a disconnection between ecological systems, flux, and the constructed environment. Dialogue and conversation occur when systems exchange information for the, in a continuous process, acknowledging and influencing each other's responses. This creates a progression of feedback loops. In a single loop conversation, information is filtered, producing a response that feeds back into the equation and produces a prescribed output. Responsive objects used in the constructed environment generally utilize single loop communication methods where one system influences another, yet the changes are merely a set of prescribed outcomes, feigning complexity by allowing for variation, yet not shaped by process. These objects therefore become one-offs or follies that are conceptually insular. In a multiple loop conversation, however, new information from each system influences future responses and depends upon cycles of response. The output is not predetermined, but is predicated on the content that continually changes in response to the systems. Through sensing, we can record data from each system and then abstract the direct relationships to human or environmental reactions. The abstraction points necessary to maintain a link between ephemeral data and the built environment then become content, location, and time. Through processing, we can create opportunities for analysis or transformation of data, such as comparisons between moments in time or translation from one mode to another. As the output of the process drives a change in form, location, and time, data are used to access underlying system complexities and relate change back to the larger system. By contextualizing output based on time and location, we can create a method to relate the moment of system and human interaction back to sensing and processing moments. Finding common modes of abstraction between systems begins to create opportunities for larger interrelationships between disparate ecological, social, cultural modes, and also opportunities to create, analyze, or accentuate patterns of linkages rather than design self-contained devices or architectures. These evolved feedback loops can allow for free evolution while maintaining stability and the design of networked landscapes that are the conduit for ecological systems to communicate with the built environment. The landscape thus evolves as a rich and fluid system of layers, providing ecological fitness and infrastructural stability, and also the interstitial becomes the communication bus that can facilitate and guide interaction. Back to Brad.
Okay, so if you're familiar with some kind of the history of cybernetics and this idea of feedback loops and kind of the interaction with the concepts about interaction with machinery, the idea here is this kind of evolution of that concept, and the concept that human beings aren't the only communicator with machines anymore, and instead we are now thinking about machines that we are constructing and their conversations with ecological systems and how those kind of feed one another and evolve with one another. What I'd like to present next is two, as you'll see, very speculative projects. One by a group of students in a studio that I'm currently teaching. This is kind of their initial concept that they're working with for the semester, but I think it does a good job of discussing this concept of how data might shape our vision of a complex ecological system. The students are listed here: Devin Boutte, Martin Moser, Kem Wen, and Josh Brooks. And the project is located in the Atchafalaya. If you're not familiar with this, the Atchafalaya is one of the distributaries of the Mississippi River. And you can see the Atchafalaya located in this red area, I guess on your left, which is this kind of leveed zone that is an outlet to the Gulf. So the Atchafalaya Basin is a vast tract of cypress swamp accepting 30% of the Mississippi River and occupying approximately 3,000 square miles of the southern Louisiana coast. This project reconceptualizes static infrastructure to manage an unforgiving and ever-changing ecosystem. The project develops a multi-scalar network of sensing technology to create a real-time model of the phenomena comprising the basin. The sensing network collects and analyzes data to monitor prevalent issues such as land loss, hyper-eutrophication, and invasive species populations. This real-time data model is the catalyst to manage ecological fitness through micro-adjustments to environmental phenomena. The model is continually updated, allowing the management to occur in small steps that are propagated to large-scale changes across the ecological system. The proposal attempts to define the management scheme necessary to express what we're calling an hyper-efficient ecology. This hyper-efficiency benefits human settlement across vast regions through the management of resources and protection of fragile habitat. In an area currently littered by remnant infrastructural elements such as levees, canals, and static land management practices, this new paradigm offers a radical alternative to current practice. Current land and water management strategies lack flexible and/or real-time responses, creating the need for a system that is self-sufficient, autonomous, and systematic. By manipulating sediment, invasive species, and algae blooms according to fluctuating needs analyzed by a real-time network, the hydrology and ecology of the basin is managed through minute interventions. This ecosystem management strategy leaves an emerging pattern in the landscape, one that is continuously computed and updated. The project implements two major interwoven procedures: sensing and maintaining. The multi-scaled sensing network provides the basis for the real-time ecological model of the basin, consisting of 4 entities, the last one of which uniquely performs the physical maintenance. To begin with, satellite imaging creates the framework for the model. LiDAR and aerial photography is analyzed on a daily schedule. On a 2-day cycle, aerial drones collect bathymetry, topography, wildlife concentrations, and the vegetation mosaic of a 4 square mile grid. For the last layer of real-time information, sensor buoys and moving processor units collect and analyze local data, such as nutrient loads, nitrogen and phosphorus, dissolved oxygen levels, water velocity, total dissolved solids, and other climate phenomena. However, the processor units are distinctive in that while providing extra detail and data coverage, they physically intervene in either sediment distribution or the growth of water hyacinth and algae. The complexity of data attained and interpolated, yielding a multifaceted ecological picture. This data is continuously collected, analyzed, and used to make system decisions, which are then relayed to the processor units to physically intervene in real-time succession. So, in wetland, sediment is the lifeblood, where a few inches determine whether an area is constantly flooded or just seasonally inundated. This proposed system physically intervenes in potentially disadvantageous occurrences in the basin, such as concentrated siltation and non-native species overgrowth. And it transforms them into potentially advantageous productions, such as micro-reforestation, water oxygenation, and habitat construction. When altered hydrology due to excessive siltation is registered, the new system removes sediment from the problematic areas and relocates it through ionization and transport. The processor units, flexible in their use and self-organizing arrangement, can flock, expand, and contract to perform various functions. In groups of expanded units, they emit micropulses of sonic waves to dissolve the substrate in places where siltation is undesirable. Using the same technology, the unlinked processor units work together to route the dissolved substrate and also any excess sediment, suspended sediment from upstream toward areas that are detected for erosion or land subsidence. The processor subsequently ionizes the suspended sediment, causing it to compact in place and to form substrate for the newly constructed land. Sorry, went too fast. In a manner similar to sediment management, the processor unit uses ultrasound to prod water hyacinth and algae blooms into harvesting. The processors link together and contract to gather the organic matter to be used as biomass and added to the constituent parts. This biomass is used in the process of reforestation to add to the new land, a layer of organic material to mimic the natural soil horizon of the area. After this land is created, the processors in its clustered form will then seed the area with an appropriate mix. The new autonomous system creates a new pattern in the land, a pattern that mimics the performance and the form of each unit, gathering, processing, and storing the needed material and information, while the system is essentially changing the ecosystem by their intervention processes. The system is sensing and updating accordingly, which creates a nuanced and real-time image of an emergent ecoregion. So the proposal envisions ecological micro-interventions, infrastructure that is agile and a nuanced response to the environment. evolving a real-time model of the Atchafalaya Basin's phenomena to transform ecological anomalies into positive byproducts. A pseudo-equilibrium is expressed and continually updated. So in this case, the main kind of driver that the students are looking at here is how this concept of having this continual vision of an ecosystem might change our management processes. And as opposed to analyzing a large landscape and making a big move, it's a process of kind of continual management, prodding, poking, and then finding the results and continuing this kind of management process. That's the Cliff Notes. Conceptually, another concept for this is this kind of large move we might begin to make. And something that some colleagues of mine, Natalie included, have started to dub this concept of the landscape as a cyborg, some sort of form that we're beginning to build with direct connections to biological systems, and something that begins to manage and evolve with the complexity that we begin to introduce. This last project that we're going to discuss quickly here is something called the Cyborg Landscape, a competition entry I worked on with my colleagues Jeff Carney and Christy Sheremy, as well as graduate student Matt Seibert. So that being said, infrastructure as we know it is parasitic. It is an external organizing framework, a prosthetic. It gains power and legitimacy when grafted to or embedded within the spatial exigencies of latency and flux. Infrastructure streamlines the three systemic natural forces that form our planetary environment: ether, terra, and water. In order to maximize the potential energy that each possesses, the flow of a river, heat from the Earth's crust, or a gust of wind can be harnessed and trained for consistency, repetition, and predictability. Within mere moments, these natural forces can be guided from their uninterrupted biotic behavior towards an increasingly abiotic condition. The study borrows as its host the first major piece of American infrastructure, the Mississippi River. Already a case study in the stasis and flux of a natural system and man's attempts to harness its power, the river is a life form, held in place through prosthetics. It is a system that functions with the benefits of both the natural and man-made, but without clear distinctions between them. This study cuts into the depth of 5 sites along the river, grafting, embedding, or suspending into each a cyborg, meant to redirect and amplify the exigent flows already at work. So to define a few kind of terms that we were using here, the first idea here is this concept of the control prosthetic. The prosthetic is the static interface between technology and ecology and the current state of infrastructure. The implementation of the prosthetic is singular, bound by pragmatic duty to fulfill a specific need and ignore contextual complexities. The prosthetic interfaces the essential biologies, momentarily reducing complexity within systems that are infinitely complex. When deployed at regional scales, the landscape is shackled, unable to respond to shifts in systems and subsystems. The second concept is latent strata. Layered, filtered, mixed, and blurred in ways that maintain an overall quality of latency, the strata of ether, terra, and water preserve potentials for eventual exploitation and alteration. Slowness and depth characterize these materials, their resting states reflecting slow change over time. Next term is pressure and flux, and these forces cause the constant reorganization of the strata. Ruptures, transformations, evolutions, the resultant force emerges based on specific arrangements of strata and the energy differentials between them. These forces indicate the productive capacity of now non-latent systems to constantly, occasionally, or gradually change the composition of materials in the system within a given range of tolerance. And finally, the cyborg. The cyborg is a mechanism of deliberate transformation. It activates tactical operations in the environment in order to incite and or simply control the transition between latent energy and flux. This mechanism is less of an object than an operation. Its objective form mutates as it becomes part of a larger system of infrastructure. It is the go-between for the programmatic responsibilities of infrastructure and the power of the latent potentials of the strata. So here we position 5 visions of a new infrastructure. Each engages fully as more than prosthetic, as the push from landscape to cyborg landscape. Each rises above the single-mindedness of programmatic change charge, and engages as a reactive and flexible strand in the most intricate network, our planet. So the first of these is something dubbed agri-power, and our site for this was in Dubuque, Illinois. Handed down from the original speculation and land division of the United States is the legacy of the grid. Through a highly efficient means of commodifying land, it is dismissive of natural systems that operate at a larger scale. As the family farm rapidly disappears in the Midwest, relic land divisions become mute, causing the logic of surface to lose focus. Driven by constant upper atmosphere winds, the agri-power machine harvests the capacity to move across a continuous farm environment. 1 mile by 1 mile plots give way to wind-specific swaths sketched into the ground with seeds and rows. The community migrates closely behind, planting, harvesting, and acknowledging that ownership now drifts shapelessly with the winds. The second is called the force field, and this is in Cairo, Illinois. At Cairo, the Mississippi and Ohio rivers converge on a narrow strip of ground. Soil and sand are pulled into a suspended state, caught in the flow patterns of the competing water forces. Into that slurry, a field of columns interject, offering to support and contain the ever-changing makeup of earth along the river. The open network provides passive, porous protection, a support armature for farming. The system allows for accretion without mandating permanence or boundary. This intervening grid regulates both existing patterns and emergent new patterns. The third is the Nascent Switch in Keokuk, Iowa. As the river bends into the topography, occasionally the opportunity to layer infrastructures presents itself. At these points, the interchange can become highly concentrated. Power generation, water flow, and means of conveyance converge to form a single loaded infrastructure. But this is also typically the point where space becomes dead, a vacuum of place, ironically at the center of activity. Instead, these layers of space can be pulled into a knot, a new center dependent only on crossings. It is a switch, a lantern powered by harvesting river flow, traffic, and wind. It is a structure of organized scaffolds, exposing layers of concentrated activity inside and amplifying the awareness of movement, force, and interchange. The fourth is the pile hive, and this is in Venice, Louisiana. As land loss and sea level rise pull at the working landscapes of Louisiana, the service industry has adapted an independent operating system that supersedes the fluctuating environments. Lift boats, floating vessels with deployable leg extensions, allow a single unit to be both boat and stable platform. Transforming this adaptation from service to dwelling, from isolated unit to collective system, lift boats inspire a solution to rising tides and shoreline recession with a series of hyper-abiotic barrier islands. This flexible archipelago of communities will protect the shore from storm surge by providing a new ground safe from dangers of inundation. The ability of the boats to establish their own ground, raising and lowering as needed, allows the structures to be site-specific by being hyper-site responsive. This boat-tuned dwelling becomes the base scale for an array of pieces that together form a functional urban fabric. And finally is Tensile City in Minneapolis, Minnesota. Separated by the Mississippi, Minneapolis and St. Paul remain distinct. Despite their proximity, isolated layers of thin connections sporadically reach across a fragile web suspended above the shifting river. Tensile City takes the expansive potential of linear conveyance infrastructure and retools it to intensify its path as a place unto itself. The lindscape becomes simultaneous expansion and densification, a thickened stitch between two urban cores. The infrastructure of the highway becomes a cable woven from a variety of urban strands, a bundle of speeds and destinations punctuated by structures and spaces. Place emerges as a suspended complex, a third city. So in conclusion, expressed within each convergence of subsystems, we find mutable, evolving relationships yearning for equilibrium. As each relationship emerges from these exocentric negotiations, evidence is scored into the geomorphologic substrata, creating our familiar landscape typologies. Labels such as wetlands, rivers, and/or deltas have the outward appearance of certainty, but in reality, each is a layered relationship where adjustments can create lakes from wetlands or vice versa. Infrastructure must then operate as a cyborg within this elemental framework, cognizant of adjustments that alter a range of subsystems. Thank you.
I'll stand. Yes. Oh, okay. There's a microphone here. Okay, thank you all very much. I think this, to start this conversation, I think it's clear to see how the ideas of technology allow us to inform, to register, to index, and also to kind of speculate on what the future implications of technology in both architecture and landscape architecture can be. What I think to start the conversation, the idea that something that Tobias kind of mentioned at the end of his lecture was that the technology is actually there. He was referencing in his case the idea of the application of passive design guidelines for architecture. The work that Brad and Natalie are doing are looking at technologies that are being developed in robotics and systems registration. This is technology that actually exists as well. Other things that exist are abandoned gravel pits in Texas. I think the interesting thing that I think all of us are looking for answers would be a discussion based on what happens in the middle between these things. We have the technologies, and then we have the speculative projects. The mine that deals with the right bacteria can deal with spoils coming from fracking fluid, with a giant Voronoi plan for Long Island, or pile hives in New Orleans. The idea that we have these speculative projects and we have technologies that exist, what happens in the middle, and how do you see these two things relating in sort of a more applicable way? And this is a question, so it kind of goes out to all of you, so it'd be nice to hear all of you discuss that. Because I think we're all interested in that thing, the role, the transition from the speculative project, between the speculative project and the technologies that exist. There has to be a place where the two things kind of combine. Sorry to put you all on the spot. And you have microphones if you need them. I don't know. Do I need a microphone? Yes.
So now I lost my train of thought. Well, the idea here about application, I mean, I think on the one end for kind of our research, that application starts very small with these, like I kind of mentioned in the beginning, with this kind of hands-on approach to testing and prototyping. But conceptually, I think that loses, I mean, you lose a lot of ground quickly in landscape just due to the complexities of how those technologies interface these kind of larger systems. So I know in Louisiana and on the Gulf Coast, and this is kind of where a lot of this thinking is occurring, I think the concept that we are somehow going to develop some nuanced approach to dealing with ecological systems. And when I say deal with them, basically that means controlling them in some way, so that not only are they robust and, to use the term resilient, not only do those two things exist, but that they also provide, they have some sort of resource for us. And there's this whole concept of ecosystem services along the Gulf Coast, and that these ecosystem services are constantly evolving through these kind of inserted technologies. And everyone is kind of moving away from the concept that the levee system itself is the correct way to do this, and that somehow we are going to have to develop a whole series of micro interventions into that system in order to allow these, these huge structures that were at one point there to manage navigation and flood control to somehow also manage ecological fitness. So I think the practical side of this is that while it may start with these kind of sensing and responses at a very kind of small level, that same idea and system we're going to have to begin to understand it to implement kind of larger scale changes in infrastructural systems.
No one else wants to comment?
Well, I mean, I think that this question of how you transition between the speculative and the sort of the available is that at one level, it's essentially beginning to put together the parts that already exist. I mean, I think in the case of what I presented, the frack water sort of recycling, you have a number of individuals, scientists, petroleum engineers, who are looking at a particular focus in regards to one aspect of the range of operations. But the issue begins to be how to connect each of those particular individuals in order to deal with the range of problems that particular sort of operations impart. And at one level, it's this, I think, the synthetic thinking that we in the landscape discipline can begin to utilize research as a way to target a number of technologies and then bundle them together in order to sort of address these questions or practices which are occurring around us.
I mean, I said this already during my presentation, that the point of showing how something could work from a technological point of view in our case is really to show that technology is not the problem, that the problem is different, the problem is political in the case of Long Island. And I think in many cases there's an extreme jurisdictional fragmentation that comes from the history of how it grew as small villages, and it's really gridlocking any innovation on the island. It's quite frustrating, actually. I don't know if this really answers your question, but the other aspect was that there's a lot of people that are talking about on Long Island and in general, or specifically on Long Island, they're talking about these separate pieces. They're talking about we need more density, or we need more, we need more open space, or we need more. We have to address the local food production, and I think we realized when we started this competition that we couldn't just work on one. I mean, the competition kind of suggested to work on one aspect, but we couldn't. We really wanted to look at the whole thing holistically and how it all connects, and I think that's also part of what is important, that that everything relates to everything on these scales. And I do realize, though, that if you try to tackle everything, that you can't get very detailed on each aspect. So I mean, that's kind of a dilemma.
This, and I think you bring a point up, and it certainly was, I think, clear in Jason's presentation as well. This issue of politics, which we're going to actually talk about later today, is one that comes up as we start dealing with technologies that do exist and projects that we can conceive of as designers. The issue of politics is what happens in the middle in terms of implementation. I think the idea of how on earth we get frack water into a quarry means you have to get this person and this person and this person to all agree on something, which is what seems interesting if we look at the diagrams maybe that T. Boone Pickens shows, or the ones that you show of his projects. The idea of using technology to promote an idea, not necessarily the idea of promoting a technology, but the technology of promoting ideas in terms of ways of figuring out how we can connect the kind of speculative project, whether it's to save the United States or to put a lot of money in your pocket, and the technologies that actually already exist. And so the idea of communication is something that is coming up a little bit as we sit here and present on this screen. The idea that maybe technology isn't about embracing the technology that we already have, but trying to figure out how to use technology to communicate projects in ways to address this issue of the political bottleneck that exists in the kind of the implementation of projects. Would you guys, any of you, like to discuss that? No.
Are you speaking about the question of representation as a means of selling technology?
In a way, I think that there's also, T. Boone Pickens also presents a lot of numbers, as do you, as actually all of you do. That's what technology sort of lends us to, is this idea of information, and how the one thing we saw in a lot of up here was big numbers. The idea that there's a lot of numbers and a lot of them are designed to be large, so the idea that they communicate an idea or an urgency about an issue that allows people to, so the idea of presenting science as a way of convincing people to do something.
Well, certainly Pickens has been quite effective in that regard. Although I have to state that at this point in time is what was it to be the largest project in the world has sort of been shelved. In terms of the 2008 recession, he lost at least half of his capital. And at this point, the turbines that he did buy, he's redistributing. But at another level, I think he presents the integration of technology in relation to economics and politics. And at one level, he's using the technology to essentially promote an idea as the red herring in order to sort of convey technology in regards to people's sort of emotional states. Wind energy is good, even though from a political standpoint, he is utilizing other means by which to essentially sort of ensure his own sort of financial well-being. And I think in that regard, the question of that the technologies may exist, but the ways that we interpret them or the ways that we utilize them are often set off by whatever the economic or political contexts are surrounding them.
Are there questions? Yes.
Do you think it's maybe easier to get somebody inspired by technology in the same way that showing somebody a big number, which may or may not be put into context that's truly detailed, but it's a way to inspire decision making. In the same way that it's harder to get somebody excited about a system, that's a very abstract thing, but technology might be a way to gain support and, or at least give somebody a concrete thing that we can get excited about. So I wonder maybe in some of your work, what your responses have been, or how have the public or the user groups that you've been discussing these ideas with, how have they responded to maybe technology is mobilizing some of these things I think that Sean is starting to suggest?
I think obviously one thing we're doing is we're throwing technology around in kind of in all kinds of different definitions, which I think is fine. And but the one aspect with that is I think this is basically our profession, though, right? The communication aspect of this is, I mean, the research is grounded, right? And that's even in our presentation, there's a whole section of the research that really is meaningless to anyone outside of us. And then that research has to slowly be distilled into some sort of conceptual framework that is presentable and digestible by the public. At the moment, I think we're somewhere in between that with our work in terms of whether or not it's even digestible at the moment, and if it's still in the realm of our own kind of heads. But even the kind of speculative project of Cyborg Landscape or the hyper-efficient ecologies, conceptually requires us to take this evolved idea of communication between machines and ecologies and apply it in some way. And that is just our, I mean, that's, I think, all of us. That's all of our normal working process. And that's our communication tool. And that's our way to affirm something or disavow it in some fashion and bring it forward for discussion. So the community, I mean, I guess on my end, I'm a little distanced from that because politically, culturally, all of these other things, I'm, in this section of my research away from all of that and happy to be. But at the same time, I understand its importance not only as a way to communicate to others, but to communicate within our own research group to have a meaningful discussion that goes beyond, discussing, I don't know, the numbers, you know what I mean, and that which, or the kind of some abstraction of the data. I don't know if that all makes sense, but I feel a little disconnected from that question, but I guess I felt like I should talk about it anyways.
I think another question that I think a lot of people have, I think Jason sort of summarized the idea that like as a panel or as a group of people at the symposia that there are there's some commonalities in terms of age and probably of interest, like in terms of how we were educated, I suppose, and that ecology was sort of built into the way we were thinking about things. The one thing that doesn't come up, I think, in this panel, and likely will come up in future panels, but the idea that it is maybe to some degree missing is this issue of people. And the idea that technology has a really good process of separating us from sort of systems, and that systems are this abstract thing, as Karen just said, And the idea is that somehow everyone just becomes a cell in an Excel sheet, or a piece in this big number crunching operation, and somehow, like, yes, my whole future has been modeled out for me in one of these projects. So the ability for, say, kind of cultural or social implications with this work is something that I think most people are probably interested in. And if I was a person that wasn't educated in such an information sort of savvy way, or I was someone that just looking at this group of work or technology in general as a process that's occurring, we as landscape architects now are, we're particularly as large-scale kind of urban landscape planners, are developing kind of simultaneously with the information age, where architects, we'd say, you think of architectural urban planning that happened in the 40s and 50s. I think of the work of, I see your project and you said Super Studio, and I think of like Hilbersheimer and Constant, and I think of things that were really just about a big idea, generally socially or spatially, but really had nothing to do with ecology in most cases. So it seems that as landscape architects, as planners, are coming into we might be losing a social agenda. Do you guys have a particular take on that? Because a lot of these projects are big in scale. The things that you're talking about are going down the whole Mississippi River. You're looking at all of Long Island. You have like Texas and Oklahoma and God knows what else. The idea that the scale that we're looking at is large. We're not doing a Garrett Ekbo backyard anymore. We're like talking about like the planning of regions. And the idea that people get pulled out of that, particularly as we start thinking about technological implications. So that's a big question, but the idea that it's something that I think is, at least in my head, looms as an issue.
When I've presented this project to various audiences, I've been accused of social engineering, socialism, being the next Robert Moses. And I thought that was very interesting, and I didn't actually take those as accusations, really. But it comes back to a political issue. I think that I think many people didn't like the top-down nature of this proposal. And that's kind of where the socialism kind of accusation came from. It's like a top-down, we're mapping this out for you. And it doesn't really go well with, the capitalist, everyone for his or her own, development, and kind of a more bottom-up development. So, but what can I say? I'm from Germany, and we're not a socialist country by any means, but there is a different attitude towards, regulation, for sure. And if you go to Holland, it's even more extreme. I mean that I worked in Rotterdam for a while, and they have some real top-down planning guidelines, and we go there and we love the architecture, we love the urbanism, and so this idea of, I think it's just I don't really have this is not really a statement of an opinion, but I think it's an interesting field to be within. Are we looking at bottom-up systems? Are we looking at top-down systems? What is actually more effective, and does it affect? Is it, where do you apply these approaches? In fact, Holland has a plan not unlike the one that we propose for Long Island. They have a decade plan of which areas they want to remain open space or actually down zone, and where the density. I think it's called the Randstad. So it's on a national scale, not just a regional scale. They have a plan, and I wonder what's the plan for the United States. I have a question for you.
Well, certainly there are a number of human costs that come about as a result, at least of the material that I presented, and I don't mean to exclude that as a way to suggest that it doesn't exist, because it certainly does. And I think if the Netherlands is a representation of sort of top-down planning as a model, Texas is one in which there's no planning whatsoever, and in fact it's illegal. in terms of having a statewide or even regional plans in regards to growth and development. And so I think the question then of, I don't know whether I'm going to be to answer your question, Sean, in regards to what's the impact on individuals given the scales that these technologies are addressing. But I think it starts at one level with the question of regulation. In the oil and gas industry has been quite effective in reducing the amount of regulations to which they have to be beholden to. They don't have to conform to the Clean Water Act. They don't have to conform to releasing the types of components in their frac fluids, and they are not beholden in terms of certain pollution standards in regards to the disposal of the water itself. And so at one level, given the fact that there is no sort of regulation or oversight, then I think the technologies are able to be implemented without concern for what the sort of people who are affected by this start to be. So I don't know. I mean, I think it's, if at anything, the speculative projects can begin to address that, hey, there are these concerns that we have to begin to deal with. I mean, at one level, the oil and gas industry in Texas certainly, probably now in Appalachia with the Marcellus shale play, is not going to go away, particularly in regard to the fact that our energy uses are only increasing. And renewables, while certainly can provide a component of the diversity of our portfolio, are not at this stage going to be able to resolve all of our particular needs given our current ambitious lifestyles. And in that regard, I think it's a matter of addressing what are the impacts of technology and reviewing technology according to these other economic and political lenses to make sure that individuals aren't evacuated from that equation.
I think for me, one of the things that comes to this, and I don't know if there'll be a question here or not, but the idea of technology and the infrastructures that we saw presented and how they relate to people, I found interesting is from Jason's presentation, it was amazing in terms of you have an 8-acre water district that's privately held, managed, and the freedoms and control that position then provides someone in a large landscape. And so I think in terms of how it interacts with people, I think about seeing the images in Matt's lecture last evening, and that is our relationship to these infrastructures. We see them, they're there, but what they are, what they're actually doing, how they're networked is very illegible to people. And I think in the Long Island project, you start to see, okay, it's top-down planning, but it's also demonstrative of, okay, this is how we're organizing things, and it's very clear the structures and relationships between things and why they are set up in that way. So he takes what might be in the Texas oil and gas example, a kind of hard to infiltrate kind of network, to one that's very legible and understandable about your place and your role in it. Why am I living in this densified space? Why is the landscape organized in a particular way? And then when I think about the potentials of the kind of responsive technologies, it feels like that could address the reality of our landscape, which isn't organized in such a kind of top-down way, but it might make available to people the legibility that the people on the inside might know. Because I'm even imagining there's the documentary Blue Vinyl, which is the lady whose family was going to wrap her home. And so she went down to the processing plants and the manufacturing plants, and there were groups collecting air samples around that plant in a very low-tech way, kind of similar to what you guys were showing with your prototyping. And I'm just imagining, right now we're all feeding information loops with cell phones and traffic and all those types of things. And it would seem to me that probably before there are cyborgs looping around 50 feet, because if you bump into me, you're dead, that kind of thing. So I think that that's actually something that brings people into this conversation, and the idea that technology can be a way to make these large-scale infrastructural technologies legible, with big patterns and big influences of environment, tangible, so that you can see, environmentalists are always small changes, big impacts, but it would be nice to get the return on that small change more immediately, and I think that's some of the potential that's really present and really current for feedback stuff.
I think coming from what you're saying, it seems like we have a history of the kind of man versus nature, and the technology is, versus the natural. And in some of the presentations, that's represented as the kind of evil, sprawling machine. And then in your proposals, it seems like there's a much more complicated relationship between nature and technology, but at the same time, very, right? So it seems like, Tobias, yours is, there's still that, desire to maintain the natural as very separate from the urbanized, although with gradation, and then in Brad and Natalie, the kind of taking the technological as a landscape itself, it seems like maybe one of your proposals. So I just wondered if you could talk a little bit about how your positioning and your view on that parallel.
I think obviously that's still, it's always going to exist, and whether I think this discussion about merging over and over again is kind of fraught with all kinds of issues. I believe, like in your proposal, the concept of kind of delineating these zones often is, a completely reasonable way to think about it. I think it's not necessarily even the delineation, but it's that kind of liminal zone and the edge, and how those two begin to interact with one another, where the system gradation is kind of the greatest source of where we can make the most interaction between them. And even in terms of kind of these infrastructural kind of concepts, it's about making those moments, finding those moments, and then having enough kind of I call it imaging, but data to understand the complexity of that relationship, and how not only the constructed environment is affecting it, but how the biological systems are, kind of working back and forth with it. So I find it more about these moments as opposed to this kind of, kind of smearing of constructed and natural, right?
That this is a very interesting question, and I think the moment of delineation and whether this is this, it's been, we've discussed this a lot when we did the competition and as we presented it, is that a hard line or is that a gradient? And even if you design it as a hard line, it's still going to be a gradient. You can't actually make, even if architecturally or planning wise it would be a hard line, it's not going to be a hard line. That's not how it works. That's not how natural systems work. There will be a gradient, and it is really, it's not so much, even though it may look like a dichotomy between urban and nature is that which is untouched. It's actually not. It's not the intent. And if you actually, we did not have a landscape architect on the team, and maybe we should have. I'm saying that now, of course. We don't actually have a great detail of the green is a green color in Illustrator at the moment. It's not a very, and the reality is that it's even though the maybe overarching organizational principle is based on the transit, and that is very kind of two-dimensional and plan-based, the reality is that there is topography, there's rivers, there's, so there, this, if one were to continue to work on the green part of it would actually be a really fascinating exercise to really see how it changes. And I would imagine that the diagram would completely, would begin to corrode, and there would be like, it's pretty general at the moment, really, because it's not years of research. It's a competition entry And I actually look forward to developing that further.
Okay, thank you guys very much.